Hello friend, my name is Derek Harder, and in this video we're going to continue our discussion of lists and using sequences in general, sequence containers in Python. So we're going to get into more details. We're going to look at member methods of lists. So there's many things that you can do in order to use and work with lists. So in this video, we're going to look at member methods of lists, and we're going to look at using lists to actually, do useful work. So processing lists and using lists to process data and work with data. So if you're ready, let's go ahead and get started. So lists are container objects, and in this class, we're actually going to talk a little bit about object-oriented programs. So you might not exactly know what that means yet, but later on we'll talk about objects and classes and things. You've kind of run across this when we talked about modules. So sort of in the same way that a module, when you import it, has a namespace, and then by accessing that namespace, you can access the functions that are part of the namespace that you import. So whenever you create an object like a list or other kinds of containers, you can access member methods of that. Directly on that list that you can create. Okay, so they have numerous member methods that allow you to work with the elements that they contain, and also provide some built-in functions. So there's kind of either use built-in operators or built-in basic functions to do things with lists, like the length built-in function, or you can invoke different member methods. So since this is kind of the first container that we talked about, I encourage you to look at the Python standard library. I'll have links to this in the description for this video, or if you have these slides, you can click on this and go to the link. So that link that I gave you should take you to the most recent stable version of the Python documentation. Hopefully that's what you're using. So if you're using a different version, you might have to be a little bit careful, but usually at this level especially, you shouldn't change too much. So in particular, there's lots of good stuff in here, but the library reference gives you links to all of the built-in containers and data types and built-in functions and things. So in particular, the sequence type, you might want to look at that. So that has documentation for these methods here we're going to look at. Maybe I'll come back and talk some more about this later here. But yeah, so if you go like the list type, by going through a class like this will kind of help you understand why this is broken up like this. So basically, you have to dig down here a little bit. So the methods I'm about to talk about, some of these might be described under the common. So like there might be some common member methods, sequence methods down here, like the count and the index. And then others of these will be because a list is a mutable sequence. So if you go and look in here, you'll find some others of these, like the copy, extend, and things like that. So to start with, to illustrate, these are only a select few methods here that are discussed in our textbook. But yeah, I'm just going to do an interactive session again to illustrate these things. So I've currently got a list defined that has 13 elements in it, so the odd numbers from 1 up to 25. So another thing, if you need a little bit of help on these, you can, I've shown this in previous videos, you can use that directory built in. So you should find, all of these, wherever they're coming from, whether they're part of the mutable portion of the list or the built-ins or other general sequence things, you should find them. And you can get help, like if I want help on the append, which we'll look at first here, I can do that, although often, these are pretty terse, but they give you the basics that you can append to a list here by calling this. So I think I'll just, starting with append, I'll just work through those methods that were shown in our textbook. So append, if I want to append a value to a list, I can call append. Now if we look at the list, it basically grows the list by size 1. It was size 13, now size 14. We've got 42 appended on to the end there. The index method will search for a method, and there's other things, so you can actually kind constrain your search to a certain portion of your list. So if I want to know the index of 17, I can ask that. So it should be at index 8. That's the first occurrence, right? So you can have multiple instances of basically the same value in a list. This isn't like a set that we'll talk about later on, right? So if I had 17 later on, I'd have to do something different to find other occurrences of 17. The first occurrence is at index 8 here. If I want to insert an item at a particular position in a list, we can use the insert. So basically it takes an index as the location I want to insert it at. So if I want to insert an item at the beginning of the list, I can insert it at index 0. Oh, and I forgot to mention, notice for all these, I'm treating these as member methods of the instance of my list object L. So I'm using L dot to invoke each of these member methods that we're talking about here. So if I want to insert a new value at the beginning of the list, make it negative 42, I can do that, right? So now I've got a new item at index 0, and everything else got pushed up by 1, right? And the length of my list is now, it went from 14 to 15. If I want to insert something in the middle, so if I want to insert something before 13 here, which is at index 7, I can do that. So now I have 9999 here is now at index 7, and everything at index 7 got pushed up by 1. So the sort method does an in-place sort, and you can reverse by saying you want to reverse true. There's other things you can do with this. So I believe if you just call sort, nothing gets returned back, but the result is that my list has been modified, right? So notice the order is now is an ascending order. Negative number. These numbers were kind of sorted beforehand, but I had inserted a couple of other items. 4299 were bigger than any of my odd numbers I had, so those end up getting sorted back to the end of the list there. So besides growing the list by inserting items, we can shrink the list by removing items. So again, here, we're going to search for value, and the first occurrence of that would be removed. So currently I have my list sorted here. So if I'm going to remove like 13 from the list, I can do that. Now the length of my list has gone down by 1. It's now 15. If I want to remove another value, let's remove the guy from the end. So now I don't have that. Now we've got 14 values in the resulting list. So you probably get an exception. So I don't know. I don't remember exactly. But if we ask to remove something, for example, that's not in the list, 53, we get a value error, right? So, and then finally we'll show the reverse. So this is different. I showed using a negative index to reverse the list in the previous video, using -1 for the step size. So this will reverse the list. So right now it goes from -42 up to 42, and you see the reverse when I did that, but that didn't actually change it in place. So my list was still the same. So the reverse is doing something slightly different. So it's actually mutating my actual list L to reverse the elements. So now my elements, after doing the reverse, are in descending order from the highest down to the lowest. So like I mentioned, there's others than are shown in our textbook here and that I just described. So this is where it's useful to understand where you can go to the documentation to get some ideas on what additional things or features are supported by these kinds of member methods, or what other ones are there, or you can always try and Google the thing you're looking for, the type of thing that you're trying to do. So, but the before I move on here, the general thing you should understand is that any container type like this is an instance of an object. So usually they will have what are known as member methods. So in order to manipulate the container, like a list container, I can call particular member methods to do different kinds of actions, insert new items, sort them, things like that. Okay. So besides member methods, there are other built-in functions or built-in operators that are defined that can do things on containers. So we looked at the in and the not in as an example before, or using like the star operator to do repetition. So a few more of those. So there's the delete statement is a general. It's really kind of works as an operator. It's not really a function, but in general for containers, that's defined in order to remove items. So we looked at remove. But that did a search to remove an item with a particular value. If you already know the index of the particular item, I can use the delete instead. Some other examples of built-in, these are actual kind of built-in functions rather than operators, but these are defined usually for containers, so you can use these to find the minimum or the maximum value in a container. So continuing on with my list L that I have defined here. Remember, I already showed remove, so if I wanted to remove the item at 17 is at index 5 in here, right? So I could have used remove, but if I already know it's at index 5, I could just use the delete to remove it. So sorry, mistyped that. So my list is actually called L. LIST is a keyword, so you couldn't create a list called with that name. So anyway, so I want to delete the item 5 in there. So now if I look at L, it should have gotten rid of that 17 out of there. Right? And again, it shrunk the size of my list by 1. If I want to know the maximum value in a list, I can use the built-in function max. So that's going to be 42. And min is a built-in function that works on most sequences. That should find the minimum values. Since it's sorted in descending order now from the highest to the lowest, the max happens to be the item at index 0, and the minimum was the one at the last index of my list here. So let's talk a little bit about copying a list. I hinted at this a little bit before, but to make an actual copy of a list, you must copy the list's elements. Okay, so this also touches on a little bit of what we discussed about pass by reference versus pass by value. So you kind of have to know in any computer language when you're creating variables or working with variables, when you're creating a new one, whether you're making a copy, so you're making a copy of an existing value, or whether you're creating something that's referencing an already existing value. So it's just another name or an alias for something. So in general, when you make an assignment of a basic type, like an integer or a float, if you assign b equals a, it's actually going to make just a copy of the value. So we're not making a new reference when the type is what I would think of as like a basic type, ints, floats, things like that. Right, so now A and B both have the value 5, but if I set A to 6, that doesn't affect B, right? So they're not references of the same thing. This actually made a copy. So that is kind of different than if you assign like a container type from one to the other. So if I make a list called L1 of a couple of items, so we've got 7 items in here, 1 through 7. And we set L2 equal to L1. So it has the items. But these are actually really references to the same list in memory here. So if I set L1's item at index 2 to be 42, now if you look at L2, this may or may not surprise you if you don't understand the difference of copying, making a reference to something versus copying the value of something when you create it, right? So L1 and L2 are really references to the same thing. So if I want L2 to be separate, reset L1 back to actually both L1 and L2. Again, since they're references to the same thing. Oh no, I'm sorry. This actually calling this made a new list. So L1 got assigned to a new list. L2 is still referring to the same copy that we had previously there. Okay, that might have been confusing. Let's start over there. So if I have L1 has these values, if I want L2 to be just a separate copy of those, I have to make a copy of it. So you could just use a for loop to do this, like I had showed in the slides. So remember, we talked about iterating over a list. So we could set L2 to be an empty list and just append values on there. All right, so now I've got L1 and L2. Here I just took my empty list and kept appending values on there, but these aren't references to the same list anymore. These are two separate copies that just have the same values in them. So again, if I do for modify L1, we modified one of the values in L1, but that has no effect on L2 since they're separate. They're not referencing the same thing. Okay? You can just use, some people, using a loop is a bit, it feels like overkill because Python is pretty powerful, so it has lots of mechanisms for doing stuff like this. So one way you might see people make a true copy of a list is using concatenation. So concatenation will create a new list and copy all the elements from the left list and the right list into the new list. So this will be a true copy of things, not referencing L1 or my left-hand list here. All right, so L4 and L1 are now currently the same, but if I change L1, let's make index 0 to be 55. That again has no effect on L4 because it was a copy. Or, I already showed this before, but you can use the trick. You might see this in code. I don't think this is very readable, but some people in code do something like that. So a slice actually makes a new copy. If you ask for a slice that ranges over the whole list, you're going to get a new copy. So L5 again is not going to be a reference back to L1. It's going to be a complete new copy of L1 here. So again, if I change L1, if I change the last element to be 66, that has no effect on L5 since it's a copy. Okay? And tell you the truth, personally, I don't know if our book discusses this here, but probably to me, none of these are really particularly readable. So there is actually a copy method which is explicitly for doing this. So if I really need a copy of an existing list, I would probably write this code. Just use the copy method, which is what it's intended for. So L1 currently has these values, and I just copied L6 over to that. So that should have the same thing. That they shouldn't be referencing the same list in memory. So if I make L1's index 1 to be 77, that has no effect on the copy L6 I just made. Okay, so let's talk a little bit about using lists to actually do useful work, right? So some of this is a little bit of some repetition of some of the concepts we've talked about before. We've run across these before. So basically, a common thing that we're going to do with the elements of a list is to use them in calculations. And since you can iterate over a list using a for loop, so using a count or index controlled for loop in Python, that's a very common thing that you do a lot in Python. So for example, let's just look at the example code to calculate the average. So to calculate the average of a list of values of integers or floats or something like that, you might just iterate over that, use the method that we did to sum up the values using an accumulator, and then just divide that total by the length of the list. So the number of the values let you know how many values in order to get the average of the values in the list. So the example from our textbook called the average.list basically does that, right? So if we have a list of 5 floating point values in this case, we can use that accumulator to get the running sum, to calculate the total sum of all the values in this count controlled or index controlled loop. And then an average is just the sum divided by the number of values, right? So we can use the length method like we talked about, right? So if we run this, we'll find that the average is 5.1. It should be summing these up and dividing by 5 to get our average there. So lists can be passed in as arguments to a function, right? So you might want to think about this a little bit before we jump in here and show an example of this. But we've done a bit with function, but we've been passing in basic types like ints or floats or strings for the most part. So lists are a little bit more complex. They're a container with a bunch of items. So what would you expect to happen? Remember, when we pass in simple types, they get passed in by value. So a copy of the value is made. So the parameter is really just a copy. So it acts as like a local variable inside of the function. Let's first just look at an example of doing that. So we can pass in something that we expect to be a list or any container type into a function here. So we'll pass in like a list of integers, right? So we could have done our previous example. This might make a good small function, so we might need to reuse something where we just pass a list and it calculates the running sum and returns that to us. So we could implement the average by taking the sum and calculating the average here. I'm going to modify this a little bit here so that we save the total in a variable. And we calculate the average. So let's try that out, right? So I kind of re-implemented the previous example that we looked at. Right. So that should make sense. If the sum is correct of being 30 here, the average of that should be 30 divided by 5 or 6. Okay. So in answer to the question I asked, so what would you expect to happen if we were to modify this value list in here? Okay. So remember, if this was a simple type, it should be being passed a copy. So modifying it shouldn't have any effect. Right? So so what happens if we modify the list we have? So let's say we modify the first item at index 0 be 42. So after we return back, let's see what is in the list that we passed in when we called get total here. Okay. So notice, everything worked because I did the modification after we did the sum and we returned that total. But we had modified the first item, and on return back from it here, the numbers list that was called main is showing that the item at index 0 is now 42. Okay, so this can bite you if you're not aware of it. But when you're passing in a complex container, effectively these are going to the local variable called value list here is referencing the same container as the one that we have when we invoke our function here, right? So making modifications, like appending or inserting or deleting from this list will show up when we return on the caller here. So likewise, you can return a list as a result from a function. And actually, as is implied here on my slide, if you do that, a reference to the list is returned. But normally what you do in that case, it doesn't normally cause as much problems as making modification to a list that's passed in as a parameter, because normally what you do is you create a new list and then you return it. So when the function goes out of scope, it's not able to do anything with that reference anymore anyway, right? And so this is usually kind of what you want to happen is if it is creating a new list and it's returning that list as a result from the function, you just get that reference to that list in the caller after you return back from the function there. So just as a quick example of that, the return list example from our textbook does that. So it basically creates an empty list, has a loop asking the user to input numbers that's going to append that list, and it returns that. So a reference to that list gets returned. So if we assign the numbers here, they're pointing to that same reference, but this function has gone out of scope after it returns, so it can't make any modification to that. So after that, though, we still have those same numbers. So if I run this function, and we enter a couple of numbers, 3, 4, and 5. After we return, we have the same reference to the same list of 3 numbers, 3, 4, and 5. There are also some nice functions, write lines and read lines, that can be useful if you're working with a file to get lists in and out of files. Although write lines, I don't know, I don't find this one so useful. It doesn't automatically write a new line at the end of each item. So I don't know if write lines is often useful. Although read lines also kind of has the opposite problem that it will read in all of the lines of a file and return a list for you from that, but it doesn't remove the new lines. So for example, if we have a list, and we open up a file and we just use a write lines on the file there of our list, the thing is it'll smush them all together because it won't put the new lines in there for you. So that might not really be what you want. Okay. So if we look at the cities.txt that was created, they're kind of smushed all together. So to use write lines, you'd have to, like on your string of items here, you'd have to your list of strings here, you have to put the new line in before you call the write lines to use that. I do find the read lines a little bit more useful. So if you look at read lines, so our textbook called this read list instead of read lines. But yeah, if you look at this, this will kind of have the opposite problem, but read lines is usually a little bit more useful. So every line will get, so a list will be returned from read lines, with every line as an element in the list, as a string in the list. Although currently my cities is all just a single line. So if we call read list, we just get an item with a single string in it. So if I want to do line-oriented processing, it would be more useful if each city was on a separate line. And then if we run it, we would get kind of more what we expect. Although, again, there is an extra new line. So if you read the text or look at the example, after it reads into a list, it goes through and does that strip to get out the extra new line that's left in there by the read lines there. And finally, let me mention list comprehensions. So you might run across these, so they are used a lot by people, although, I mean, personally, I find them maybe not so great for readability, but they can be convenient in lots of cases, so you ought to understand what's happening with these. So a list, you can use comprehensions for most all container types in Python. So if you understand list comprehension, you'll probably be able to understand what it does for like a dictionary or set comprehension. Same kind of idea in all these cases. So it's really like a syntactic shorthand for a for loop, right? So if I wanted to, here's another way of copying a list, or this is the same way of copying a list I showed before, right? So we start with an empty list and just append the items. So another way of copying a list was we could have used a list comprehension here, like this, right? So here, if I have my list 1 already defined, I'm actually going to be making a copy. So list comprehensions makes copies, it creates a new list, and then this for loop syntax that I'm doing in here is how the new list is created. So it's basically creating a new list by iterating over the items in L1. Okay. So if I change L1, it's not modifying L2. But these list comprehensions can be a little bit more useful than that. For example, if I need a new list that's the square of the items, I could do that. Now L2 is going to be just the square of my items, which is the square of 42 and then 2, 3, 4. Right? And look in our textbook for other useful examples. So there's many other kinds of things you could do with list comprehensions like that. Okay, so that's it for our discussion for lists. In this video, we looked at some more of the advanced kinds of things you can do with the lists. So once again, lists are container objects, and since they're objects, they have what are known as member methods that allow you to work with the elements that they contain. So we looked at a couple of them. There's a good dozen or so member methods that you can do with lists. So things like sort, append new items, remove items, find the index of a particular item in a list, that kind of thing. So be careful when copying containers like lists, so that doesn't do the same thing as when you're making a copy of a fundamental type like an int or float. It actually makes a new reference to the list type. So especially when you're passing lists into function and returning them from functions, you should be aware of the difference between copy by value versus copy by reference that happens. So in general, you can process lists using a count controlled loop, using a for loop. That's basically what the for loop syntax in Python is meant for. And we looked at some other things like doing list comprehensions. So you should be aware of what a list comprehension is. You'll probably see lots of those used a lot in existing Python code. Okay, so that's it for this video. I hope that, as usual, you're finding these things useful. Let me know if you have comments or questions about things. And I hope to see you again in class.